No VLA policy items so far could truly generalize. All of them just did a small set of tasks from the dataset, you fine-tune them on. But MolmoAct2 creator state it will do anything you prompt, just out of the box, with no pre-training needed at all. How does it possible? My name is Grigory and in that video we will test the MolmoAct2 policy. I'll check if it grabbed the thing I asked with no fine-tuning at all. Then I will show you how to fine-tune that model to, maybe, increase its performance. And finally, we'll try to run it on the completely different embodiment, the drone, and we will see if MolmoAct will be able to fly. Welcome. I was wondered to hear that MolmoAct2, as the first VLA model, does not require any pre-training. It just works out of the box without you needed to fine-tune it for any specific task or object to manipulate. At least, according to what producer state. For now, I'm quite skeptical about it, but I want to convince myself I'm wrong. Let's try it. Official Hugging Face page of the model contains an example code showing how to run the model, but unfortunately it uses the single still image and hard-coded input vector only. Here's no explanation how we can connect the model to our arm. We can try to wire it manually, but luckily there's a guy called Irene Grace who did it for us. I'll clone the repo and install the requirements. But there is a problem with that library. Unfortunately, it uses the RealSense camera as the main camera of our robot, while I have, and most probably you too, the usual simple cheap USB camera, the OpenCV tag. We need to dive deep into that code and replace the configuration of the RealSense camera to that usual USB OpenCV camera to make it work. Okay, so I will ask Codex just to find that RealSense camera things and replace it with normal USB OpenCV camera. After, I need to make ARM calibration, find ARM and camera port names, solve a few bugs in the code and so on. I will not go in details to save your time, but if you want me to show such details in another video, let me know. Oh, okay. For some reason it does not want to work. Okay, in fact, it should be not SO101, it should be SO101 follower. Ta-da! And it wants to work. Very good. Downloading the model will take a while. Well, here also new prompt to pick up the yellow rubber duck. Every VLA before this required you to collect around 50 teleoperated episodes and spend few GPU hours on fine-tuning for that exact arm, object, or lightning. Move the camera or swap the object and you need to record whole the data set. Let's go, let's test the code and let's see if actually our MolmoAct on the SO100 arm will go into work. Zero shot, with no data set prepared. Whoa, it started to move! After some code approval, whoa, it even tries to grab a duck! Whoa, it did it! Oh! Whoa! Oh, oh. MolmoAct just works zero shot. Now I'm asking him to place the rubber duck into that green card. Let's see if he's going to do it. If you want to see my fork of the repo with the camera and other fixes, let me know. Okay, let's go, let's do it. Yes. Okay, he grabbed the duck and yes! He placed the duck in the green card. Very good. And in the next experiment, I want my robot to prove on the CAPTCHA that he is not a robot, like in the famous meme. But I realized that MolmoAct zero shot checkpoint just can't do it. As we can see, our robot without pre-training cannot touch the I'm not robot checkbox. The duck works zero shot, but screen with CAPTCHA won't. Is there any way we can help our model? Obviously yes. This is the task where we can fine-tune our MolmoAct model. And this is the perfect moment where I can show you how. First we need to collect a dataset about 30 to 50 episodes of how we showing what our robot needs to do. Need to touch it fast and once. Oh, and only then it works. So what I'm doing now, I'm removing bad episodes, like for example this one, where I just missed the button, and concatenating datasets. My dataset is here on the hub. Okay, so to train the model, first of all we need to go to the robot documentation with MolmoAct2, and there's two ways of training, with original MolmoAct2 weights, this longer command, and ported robot weights, which is a little bit shorter. So I will start with original one and we'll see if it will work for me. If not, I will switch to the robot ported. And we need to change few parameters, as dataset name, our camera names, base policy checkpoint, and so on. But training don't want to start. It tells that model just too big for my 24GB VRAM GPU. After some debugging, I finally make it fit. First, I needed to switch the action mode from boss to continuous. Model can output actions as discrete or continuous numbers, or both of them. But we only need the continuous actions in case of our arm. Second thing, I set up it to train only the action expert head. Our model consists of two parts: the big VLM that is responsible for reasoning and word understanding, and action expert, which is responsible to produce appropriate actions. Unless you're not going to change something fundamental in the model's word understanding, the training of action expert only is completely enough. Training finally started! Honestly, training of MolmoAct2 is much more complicated and requires more knowledge than training of the classical VLA models. But still, it's doable. After 15 hours of training, 15 hours, not like 1 hour like in case of the small VLA, my model is finally ready. But does it mean that model going to work 15 times better? Okay, let's try an inference. Okay, and robot, what will do next? Okay, it's trying to do it, Let's go! Inference! For some reason it does not want to click the button. Let's go! Do it! Go! Do it! No! For some reason our sync inference just can't click that button. I just wait in that moment before the clicking it and just stands endless in that moment and does not click the CAPTCHA. And unfortunately, I know what's wrong. I recorded the dataset badly. In every episode I recorded, I paused to line up with the checkbox before pressing. So the model learned pattern to approach the checkbox and wait. It never learned to click. I decided to re-record my dataset. This time I make a smooth movement without any pauses. I retrained model and... Okay, so this is the inference of our second dataset and... Yes, you see, the robot touched it, but does not click, unfortunately. CAPTCHA needs to be too resistant for touch of our robot. It needs to touch stronger, probably. Our robot does not touch like a human. This is the problem. Oh, yes, he did it. Wow. MolmoAct also confirmed that he is not a robot. Let's try it one more time. Seems not this time. MolmoAct finally performed a task, but on the 10th try or so. It works, but it's far from being reliable. So as a sanity check, I trained a second model, X-VLA, on the same dataset. Test an X-VLA model. Oh! It did it! It just did it! Wow! Go. Click it. Made it again! Very good! Again, he did it! Wow! XVLA just did it! Amazing! How is it possible? And I know my dataset I recorded is far away from being perfect, but I can see that XVLA model can just click that I'm not a robot button just much more often than MolmoAct. XVLA model also been trained for 1 hour only. not 15. And yet another problem with MolmoAct, it preloading more than 1 minute before every operation. This is something that, in my opinion, is just make model actually unusable in every production environment. So as far in my experience with MolmoAct for now, I can see that it's really powerful model if you want to achieve generalization. It just understands the things. You can grab the object from zero shot without pre-training, but if you need to do pre-training, it's big model requires a lot of resources to train and to interfere it. And don't get me wrong, my purpose is to share my experiences, not to criticize the LNAI team, the creators of MolmoAct2. They're doing a great job creating the ton of different AI models, some of which could be also usable in robotics. By the way, if you want me to test their other models and have any idea what I can actually do with that models, let me know. Let's check out if our MolmoAct will also be able to change its embodiment and will be able to fly a drone. But before we go to the final series of experiments, please support the channel by leaving your like and subscription. This way, you will help to develop my channel faster and motivate me to produce more quality content for you. So, in previous video, I recorded a dataset of our drone flying to the different objects like apple or orange. So I want to use that dataset and train my MolmoAct on the same dataset. It's not actually the previous video, I recorded it already but not published it. It will be next video, in fact. I also create the client-server script where the server will run on my remote PC and client will run on my laptop and send calculated actions to the drone, while server will be just calculate actions and send them to my laptop. And I can share that code for client-server if needed, just let me know. I trained the MolmoAct2 on the same drone dataset. Feel free to use my command. Also fun pro tip, when we change that number of processes from 8 to 1, which is completely fine when you have only one GPU, your time of training drops just significantly. 15 hours like before, my time dropped just to 8.5 hours from 15. It's time to test our MolmoAct on the drone, and now the task of our drone tool is to approach an apple. We will find the apple, we will approach the apple exactly or some other object, we will fly somewhere at all, we will see in a minute. Okay, drone started, and model start to execute, and drone flies, actually it flies straight to the apple, wow! Same as the dataset. Wow, drone with MolmoAct approach the apple. First success. It sounds amazing. Now it just stands in front of the apple and does nothing. It's exactly how it should do. Let's repeat. It was the apple from its side. Okay. Oh, you see that? You see? Okay, it found the apple. It found an apple. Wow. Let's try with different objects. With orange, for example. And it goes to orange, it goes to orange, yes, it goes to orange! Very good, it goes to orange! Wait. So we can actually see that our drone is able to approach the orange. But what about to complicate his task? So our drone been trained only to approach the apple and orange and the jar of hearings, the object you can see here. It now been trained to approach a bottle of milk. What will happen if I ask him to do so? Okay, it goes. Where it goes? Let's see, it goes slowly. It goes very slowly, but it goes straight to the milk. Whoa! You can see it, it's never been trained for it. Never seen that bottle in the dataset. But it approached it. You can see it, it's... Wow! I want to ask MolmoAct to do something it's been completely not trained for. I will ask it to approach the table and land on the helipad. The model been trained only to approach the different things, but never been trained to land on any objects. Okay, it goes. It sees the helipad? No, it goes too far. Just miss it. It's just too high. It can see now. It cannot see. It goes to the orange helipad. It goes to it. It understands where is the orange telepad, it goes to it, but it cannot land. Unfortunately, drone have no downwards camera, so if it will be able to sit down, I guess it will be able to land. But now it just lost the helipad from its front camera and can do nothing. And it's time to go outdoor. In the next experiment, I want my Tello drone to follow the Earth rover, the car I used in my previous video to make distance with LM from one city to another. And this time I will control the Earth rover remotely, trying to escape from the Tello, and task of the MolmoAct model will be follow the Earth rover independently where it goes. MolmoAct never been trained to follow that Earth rover. MolmoAct never been trained for this environment. All the training data is just made in my room, so will it actually work? Let's see. Oh, going straight to the rover. Wow, wow, it found it and goes straight to the rover. Wow, wow, it follows it. Okay, let's try to move with our rover. What will happen? It lost the oh, it seems it lost the rover. Oh. The model was totally not trained to find the target when it loses it from sight. If target lost, it can do anything. Obviously, we can train model to rotate and search in such situation, but this is the idea for completely another video. Okay, you see, this time it goes to the rover. This time I found it. Let's try to make some movements. Wow, you can see it follows it. It follows the rover. Oh no, it kind of follows, it not follows anymore. Wow, it follows it till the near obstacle. Okay. It goes to the rover, very good, very good. Rover escaping, but drone follows him. Okay, drone still follows. Rover escaping and drone follows after it. Okay. No, not go into the tree. No, not there. MolmoAct2 been trained indoors to approach apples, step outside and is able to, sometimes, to chase a moving rover it never seen before. It's really close to generalization. So what do I think about MolmoAct2 and should you use it in your projects? I've been really amazed by the fact that model been able to work just out of the box without any pre-training and grab the things from my table like rubber duck or whatever, and all the other VLA models I tested earlier requires to collect dataset, to spend time on training it and so on, but MolmoAct just did it out of the box. So if you don't want to spend time on collecting dataset and training your model, then MolmoAct is great choice for you. Just start out of the box and see how it works. Also, if your use case requires a big generalization, so when you're working with the not only apples and oranges, but with whole bunch of different fruits, and you just can't collect dataset showing robot how to grab every of that fruits, the MolmoAct, again with its generalization ability, is great choice for you. But there are also downsides. MolmoAct is a very big model. It trains longer than many classical VLA models, and what the worst thing about that model, you need to wait for more than 1 minute every time you want to preload it before the operation. And this, in my opinion, makes that model completely unusable for any production use case. Just imagine the robot in the factory approaching the table with parts, and before grabbing any part, it needs to wait for more than 1 minute for model to load. And it's only my opinion, feel free to disagree with this, but for many classical use cases when you have just few objects to operate with and you don't need big generalization, the much smaller models as XVLA or even simple ACT will be completely enough for you. By the way, if you want to learn more about the classical VLA models, here I prepared a video where I test and compare few of them: ACT, small VLA and Pi 0.5. I test their performance, time of inference and required GPU memory. And that's all from my side. See you next time.